Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios. And what I have for you today is a reaction to a thread by Dave Anderson about 10 commandments of legacy code. I usually don't like commandments, so I thought about how about reacting to what he is talking about, because as you know, I'm very passionate about legacy code. I quite love working with legacy code. Before we move on, just to let you know, I'm now recording from our new studio. Actually, the past week's video has been also recorded from this new studio. And I'm curious if you see anything different or anything that needs to be improved. We try to replicate the same setup, but as you well know, things might change. And it was quite an adventure to get here, so because of many things. But anyway, we are now in a new studio, and actually I'm gonna use it all next week for yet another secure coding training, and it's gonna be really fun. But let's go back to what we were talking about. This is the thread by Dave Anderson at Scarlet Tinct on Twitter. And what I don't know him, but he is an ex-GM and tech director at Amazon, ex-CTO at Bezos Academy. So quite some credentials working at Amazon as a tech leader, as a tech director. This is quite a feat, right? So let's see what we can learn from his take on legacy code. If you are a software engineer, your main job is maintaining legacy code. Why? Because building a system doesn't take long in comparison to how long code will last, assuming the code business are successful. Here are the 10 commandments of maintaining legacy code. Right from the introduction, I agree. Also, on the other hand, what I would like to see is that we put more work into making legacy code not being legacy. Michael Feder has defined legacy code as any code that doesn't have tests, automated tests. But I usually like to go a bit deeper and talk about how you feel when you see that code. So for me, legacy code is any code that you are afraid to touch or to change. And because of this, of course, having tests is one way to deal with this, a very powerful way. But sometimes there are other ways, like maybe you cannot test everything, but you have good documentation, you have good, or you have people in the team who know the code really well, and you can pair with them, or you are doing some kind of social programming, like pair programming or ensemble programming, and then you can remove the fear this way. As we well know, there are I have this hypothesis that every problem in software development has multiple solutions on a socio-technical continuum. So some of the solutions will be social in nature, some will be technical, and I think one of the technical solutions is also one that I would like more people to actually try out, which is refactoring legacy code through pure functions. So I think it's a very powerful method, but it needs more people to try it out and actually see what are the goods, the bads, what are the limits of the method. But you can find out more about this from other videos on our channel that discuss specifically this topic. So I agree with the introduction, but with the only observation that if you take care of your legacy code, it won't feel like a legacy code. Commandment 1. Thou shalt not complain about the code. Your coworkers wrote the system, they had good intentions. When you presume that it was built wrong, not knowing their situation, you insult them. Respect what came before. I think this is a very important thing, and I have been guilty of doing this kind of critique in the past. When I was a junior programmer, I was always pointing out faults in other people's code, usually people who weren't there anymore. But the thing here is everybody wants to do a good job, and this is a good assumption to make. The only thing that can come out, well, there are many reasons actually why code can come out wrong, and some of these are because you are dealing with unknown, and you are dealing with unknown under stressful conditions. So it's very important to understand that. Another thing is that you always need to make trade-offs, and sometimes you don't make the best trade-offs. I mean, there's a saying that says, when you look back at the decision, you have a 20/20 vision. You have the best view of that decision possible, and of course you can say, oh, now if I were to make this decision, I would make a different one, right? But the problem with this is that you are not in that context. So trust your colleagues, and it's not very helpful to complain about the code. You are where you are, okay? Maybe you need to vent a bit, and that's fine. But you are where you are, and you need to play the ball where it is. So that's basically the thinking here. You start from where you are and you improve things, right? It makes a lot of sense. Wasting time complaining about the code, not that great. It doesn't help a lot. Commandment 2, thou shalt not permit tight schedules to ruin your system. Doing it right to take 6 weeks, but we could probably hack it in 2. No, never provide that option. You can skip features, launch later, add engineers, but never make your job harder in the future. Very important thing, many people misunderstand the term technical debt. They think that technical debt is we are doing a poor job now because we go into a rush and then maybe we'll fix it later. This is not what technical debt was supposed to mean. Technical debt is supposed to mean that in the initial definition, the initial metaphor was that we are building the system based on the knowledge we have at that point, but once we develop it, we learn more, right? And so technical debt is about the difference between what we've learned and what we know now versus what we knew 2 months ago when we wrote that system. That is where technical debt comes from. And this is a natural thing to happen to systems. You always learn more things. Actually, you know the most of your system, of your product, when it's done. And nobody's using it anymore, right? When you stop maintaining it. That's when you know the most. But the problem is you're always dealing with little or less than full information, right? You're always dealing with partial information while building the system. Right? So you need to do things right, because otherwise what you will do is just create problems for yourselves. Never make your job harder in the future. Cool. So I like this one. And of course, people will ask me, okay, but what if there's pressures from manager and so on? You can always explain the consequences. So if there's pressure from managers, I always explain, okay, this is what will happen. We'll have a bunch of bugs. We'll need to fix them. It will take us longer. And okay, there are some circumstances when you need to make this. So one example is you have a hard deadline. You need to take the product out at a specific date in order to show it at an exposition, or I don't know, hit some kind of launch date, and you can skip features, right? That would be the good way of dealing with this. Sometimes it's hard to make that. So what you could do is to explain what will happen, and that customers will be unhappy, and then maybe even offer an alternative. This is one feature that we could skip, right? So always be very careful when you negotiate. It's ideal not to have these types of negotiations. It's ideal to have a trust relationship here. And then if your managers trust you, or if your product managers trust you, then it's easier. But if you don't have this kind of trust relationship, sometimes you need to put in more effort to explain and come with good arguments why you need to make it that way, right? Commandment 3, thou shalt not put orphan features in your system. Keep your code simple and purpose-built. New requirement which doesn't fit your system, hacking it in regardlessly is rarely the right answer. Keep system simple and purposeful. Make new ones when necessary. I like this one a lot. And I've seen this far too little in our industry. It's often a fight and a grind to add more features, add more features, add more features. Yet there are people, like if you look at the philosophy of 37 Signals, the people who built Basecamp, what they did was they said, we'll build only the features that make sense for this product. And we will refuse again and again a number of features. So, for example, Basecamp is a tool for project management. So what do you think about when you think about project management? Well, many people think about Gantt charts. And they refuse to add Gantt charts because that would needlessly complicate their product, right? It's not a product for everyone, it's a product for a specific audience, and it serves them extremely well. So keep system simple and purposeful. Now, do you want to add features but they don't feel right here? Yeah, make a new system. And the same thing can apply not only to products but also to back-end kind of software. So yeah, good one. Commandment 4, thou shalt not rewrite thy system unless thou have considered all other options. Seriously, engineers love rewriting. Existing systems are hard to understand, and modifying a system is mentally harder than rewriting it. It's rarely necessary, don't be lazy. This is such an important thing. I often hear about rewriting systems, and my first question is, okay, do you know all the bugs in your system? Because somebody is probably using that bug as a feature. So this is one big problem. Rewriting a system, particularly with people who do not know it inside out, it's extremely risky and invites failure. So if you have, maybe if you have the original people, the original team who built that system, and they perfectly know what's inside it, they have good documentation, they have that knowledge, and it hasn't been that far along, maybe then you can rewrite it. But if you are in this context, you probably don't need to. Most of the rewrites need to happen when you have a team that doesn't know what's in there anymore and they find it hard to change things inside. And the new technology comes over that seems to solve all your problems, and trust me, it won't. Okay, sometimes you are forced to rewrite. One example was Prezi, for example. Prezi is actually a company that builds a product that present for online presentations, but they are done in a nice way based on mind maps. And the initial version of the product was for Flash. And then Flash was not used anymore. And first started with Mac OS blocking Flash, and then more browsers followed course, and then of course they had to rewrite it. Okay, this is a forced rewrite, so you must do that. But in that case, you need to start also first by looking at the system and making sure you understand. One way you can do it though is if you have the old system and you start writing the new system, and you can call the old system and the new system and compare the results. This is one way to reduce the risks for rewriting. But it's ideally not to go there unless you really have to. And really have to is a big hurdle. So don't say, yeah, we really have to because there's a new technology and it will solve all our problems. It won't. It will just create other problems for you. Commandment 5, thou shalt not be afraid to create new systems. When you have a new customer feature, consider creating a new system to support them. Complexity is the root of expensive maintenance. 5 simple systems are far easier to maintain than a single complex one. Yeah, I agree with this. Try to create more systems. You have a new customer, a new feature, create a new system. So think about it as modules. I always like to think about, and I think this is something that we are missing in modern architectures, or it's not at the center of modern architectures, although it should be. This idea of a module that has a clear purpose, it's purpose built, and then it's well documented, it has a strong boundary, and you can replace it with another module when you need to. That does the same thing, but better, right? It's easier to do things in this way than maintain a single complex system. Now, what I wonder though is what he means by system, because system can mean a lot of things. So is this about things like services, or is this more about things like, is a system a combination of multiple things? Usually when we use system, it's a bit misleading. It can mean a number of things, so maybe people understand different things. But when I see system in this context, what I'm thinking of is modules rather than a very complex thing. Commandment 6, thou shalt learn the system before changing it. never accept a mystery system. It can be grokked with some effort, do that, or it makes no sense at all. You can fix that, or it's so huge that no human could comprehend it. Break it into smaller pieces. I quite like this. Yeah, so sometimes you can understand the system with some effort. Basically, it depends on the knowledge you have. The knowledge problem in software development is quite a big one, right? I've worked with teams who had no knowledge left of the systems they were working on, and that was creating a lot of issues. And it's very, very hard to recover from this situation. The only way to do this is by rebuilding the knowledge, and that takes a lot of time. There are, however, ways of rebuilding the knowledge for systems. And some of these techniques are related to the legacy code techniques. A large part of the legacy code techniques are about understanding the system. And you can actually understand existing code without reading it, because trying to understand the existing code by reading it is usually, unless the code is extremely clean, this is usually very difficult. So if this happens, then what you can do is to start writing tests just to help you understand what the system does. And you can do this. And it's so huge that no human could comprehend it. Then, of course, solution is break it into smaller pieces. And this is something you can often do mechanically. You can make a dependency map of the classes in your system. If we are talking about a kind of a monolithic application, and then based on those connections, you can refactor things, push things in different libraries, and then maybe refactor those libraries to be services and so on. This is one way of doing that. Of course, there are other ways, like you could do the domain-driven design approach, which is do a domain modeling and then figure out where things need to move, right? Even better. But in order to do that, you need access to domain experts, most likely. If you cannot do that, then you can go with the technological approach, which is look at the graph, push things out, and so on. Right, the kind of architectural refactoring first. And then you break it into smaller pieces, and then you look at each piece. Or you could, instead of doing this refactoring, although that's what I would do most likely because it helps clear my mind. But let's say you have a big monolithic and you don't want to do this kind of refactoring. Fine, you can still deal with that in other ways, like split it logically into pieces and then take each piece separately, right? So these are a few options. Well, never accept a mystery system. When I am called to deal with legacy code, I usually work with mystery systems. So this doesn't apply to me. I treat the system as a mystery system, and I start from the code. My mantra there is, in code we trust. I don't trust the documentation. I don't trust what people are telling me about the system, because none of those things are complete. And the only thing that is the truth of the system is in the code. So I need to work with the code in order to understand the system. And sometimes I don't need to understand it. So I understand the system by refactoring it. I understand the system by testing it. Right? Commandment 7, thou shalt repair windows, not break them. Every code you touch should look better than when you found it, not worse. Add tests, refactor, update variable names. Every single estimate should include non-stated, non-negotiable time to progressively fix things. Yeah. This is also known as the Boy Scout rule. Every code you touch should look better than when you found it. I think the Boy Scout rule has another name now, or an alternate name, but I don't remember what it is. So if you remember it, if you prefer another name, let me know. But fundamentally, I don't care how it's called. The most important part is this. Whenever you touch a piece of code, leave it better, leave it cleaner than it was before. Add one more test. Rename one variable. Extract one function that makes that adds to the comprehensibility of that system. Of course, within the system constraints, right? I mean, if you are very focused on performance, think very carefully before you extract a function, but usually we don't have that issue. Add tests, refactor, update variable names. Yes, this is something that you can do, definitely. It won't take you long. It will just take you maybe 2 hours more. Renaming, particularly with modern IDEs, quite easy to do. Right? And every single estimate should include non-stated, non-negotiable time to progressively fix things. Yeah, if you're using estimates, this is one way of dealing with it. The other way is, anyway you have estimation errors, 2 hours plus or minus doesn't matter that much. It's the estimation error anyway. So, Commandment 8. Thou shalt not neglect the framework of thy system. While teams will sometimes improve their legacy code, they'll often neglect the build processes, deployment, or testing framework of their systems. Refactoring is not just about code, update everything. I agree. And actually, whenever I started a new product, the first thing I did was set up the build processes, the deployment, the automating deployment, and so on, the testing, everything. And once I have that, you always need to update it. Like every other week or so, we need to add something more. We need to add another library, another dependency. Improve it a little bit, optimize the build. There's always something to do there. And when you have existing code in a big code base, it's likely that you'll need to improve this even more. Sometimes you have technical debt in this area, a kind of automation debt, and you need to deal with this. Absolutely. Now, it's a bit weird that he calls this the framework, but usually when we talk about frameworks, we think about, the framework that we're using to build the application, like React.js or what's the one for Java? I don't remember right now, doesn't matter. You understand what I mean. Spring MVC, for example. Okay, that's good. But when he talks about the framework, he means everything, all the automation processes, all the automation that you have for your code. Absolutely, you need to update everything. Commandment 9, thou shalt use tests to refactor safer and easier. Don't understand the system, refactoring, add tests as you learn it. Tests are a great way of adding predictability to a complex system. They are often the best documentation of how a system should work. I agree Absolutely, this is a very good piece of advice. I would add to this, I learn more about a system by writing tests than in any other way. So, ideally, learn the system by writing tests through programming, ideally by programming with other people. So, pair programming, ensemble programming, these are excellent tools for understanding a system together while adding tests. And that is a win-win-win proposal. You are understanding things, you are storing what you understood in tests, and if you are doing some kind of social programming, then everybody else understands the system as well. It's such a great way of improving your knowledge of existing systems. Commandment 10, thou shalt build a minimum to gain the value. One way systems become hard to maintain is by building to be infinitely extensible. Strangely enough, that makes them less flexible because future engineers can't understand them. Think ahead, but build for now. Yeah, this is, I think, one of the most challenging things. We like to think about all the possible situations and open to the future, our systems, and I think we are often doing this in a wrong way. And remember a few things here. One of them is the rule of three. Only after you see the same solution 3 times, then you abstract away. So introduce abstractions only by starting from very concrete examples. You need a few concrete examples before you can start introducing abstractions. This is a good way to think about this. Now, if you are a good experienced designer, you can maybe do these cycles in your head or by writing them down, but be very careful because bad abstractions create a lot of problems in the future. So be very, very careful with this. All right. So these are 10. Okay, and I also like this idea actually. Build a minimum to gain the value. Always think of, the way I like to think about things is, as engineers we get problems to solve. I know they come in form of requirements sometimes, but really what they are problems. And if you ask why we need this requirement and so on, or sometimes it's described in the requirements, you understand what the problem is. And then what we can do, and one of the things I've learned as an engineer, first of all, and I think in the first courses at the university, is that you don't have to solve 100% of the problem. If you approximate a solution to like 90% of the problem, that's good enough. And often in software, we can start by taking a big problem, splitting it into smaller problems, and then try to solve like 90% of each small problem. And that's it. And at some point, maybe your manager will look at that and say, oh, that's actually enough. You don't need the rest. And that's how we do things, all right? So it's better to build little by little than to imagine all the possible situations and build everything and then realize, oh, now it doesn't work. Oh, now we've created a lot of problems for ourselves. Right, So these are the 10 commandments. Let's go through them once again. Thou shalt not complain about the code. Yes, I agree. Thou shalt not permit thy schedules to ruin your system. Yeah, absolutely. Thou shalt not put orphan features in your system. Actually, add as few features in your system as possible or create a new system, right? Thou shalt not rewrite thy system unless you have considered all other options. Yes, absolutely. Thou shalt not be afraid to create new systems. Yes, I agree. Thou shalt learn the system before changing it. It's incredibly important to do this. Thou shalt repair windows, not break them. Yeah. Thou shalt not neglect the framework of thy system. And here, what we mean is the build processes, deployment, and so on. Thou shalt use tests to refactor safer and easier. And I would add also to understand the system. Thou shalt build the minimum to gain the value. Yeah. So, strangely enough, I actually agree with this. I usually don't like commandments. In software development, I believe many things are very contextual. And of course, with these things, you can also imagine some weird scenarios when they won't work. But I think that in most situations, you can follow these and you'll actually get a lot of value by following these 10 commandments. I absolutely agree. Now let me think. Would I add something else? I think I would add that something on around working as a team to understand the system. So don't see this as an individual effort. Instead, try to use the full brain power of your team to go there. And in order to do that, you can do pair programming, you can do things like coding dojos, you can do ensemble programming. These are social programming techniques in which you can combine the technical things with the social things and you get the most value out of it. And I think it strengthens you as a team while also solving real problems for everybody. This is what I would recommend you to do, like maybe 11th commandment or 0th commandment, I don't know. So, are you working with legacy code? What do you think about this? Is any of this helpful? Is any of these things something that you cannot apply at all? Why can't you apply them? Let us know in the comments. We love comments and we love to answer comments. So I can't wait to hear more from you. Thank you kindly for the view, and until next time, remember to think, design, and work smart.